Hi, I am Badri Sharpana. I have over 25 years of experience in technology and business leadership. I have worked with companies like Millipore and Integris, who specialize in providing devices and solutions to customers in the semiconductor and related applications. Today I am going to talk about gas delivery technology using mass flow controller, MFC for short. I'll be talking about what are the principles of the technology, where it is used, like the processes, and how are we going to face the benefits of these processes. MFC or mass flow controlling technology is as old as 1960s. It was used by a company called Thailand General and was used for our mission to the moon. And Thailand General was acquired by a company where I worked for, Millipore, and later it became Microless. This is the background about myself. And as you can see here in the photograph, what we are showing is a digital mass flow controller. Prior to this, we had what we called analog mass flow controllers. What does this product consist of? It consists of a sensor, you have a valve, and you have an assembly of both of them in a compact footprint. Why is gas delivery technology important? Our lives, if you see here, we have starting from what we eat to where we go using what, and to taking care of our health and the devices which we use. You'll be surprised. Somewhere this gas delivery technology is used to give us accuracy, repeatability. That means what we want, we will achieve, and we do it every time. How is it achieved? The heart of a mass flow controller is what we call a sensor. A sensor is typically a heated, small diameter capillary tube. The gas enters through the assembly. You do a small sampling, measure the actual flow, use the PID circuits, proportional, integral and derivative control, and give an accurate output. In the older technologies, the analog technologies, the accuracy was not good. As technology progressed, we are able to get finer accuracies, which is visible here from this graph. You have the digital, you have analog. We also use a lot of gases in the application, and so you have a multi-gas recipe possibility in the digital circuits, in the digital mass flow controllers. We use common terms like set point, which is primarily the instruction for a mass flow controller to do something. We need to calibrate it like any other instrumentation. As I said, we use the PID control. We use the seals and fittings depending on the gases which we use. The gases which are used typically in a semiconductor process start from the inerts like nitrogen, argon, helium, and goes to hydrogen. Then you have phosphine, arsine, very toxic gases. So for each of them, we use a combination of different seals and fittings, and we use various communication protocols like RS-485, DeviceNet, and Profibus to make sure that we have a communication and shareability between the tool where it gets mounted. What we have to remember is MFC is a subsystem. It's a part of the bigger machine, and the technology drivers for this are what accuracy we want in the process, what repeatability, how is the process advancement going on, how are we able to control the performance, and what communication protocol we use. Having said this, let's go more practically into our lives where we will see the impact of the technology. You see in this ring a sample of the various processes which uses this technology. One is diffusion, which is used in IC devices to make semiconductors. Dry etch, again a process which is used in IC devices to clean up during the process. Coating, tungsten carbide. The ones which you see here are say typical inserts which you use in machine tools for metal cutting applications. Analysis, flue gas. It's like to find out what contamination are we releasing into the atmosphere. How are the engines going to perform? Are we getting something which is compliant with the norms? So using a gas chromatograph here, which uses mass flow controller technology to do the analysis. Sputtering, primarily to deposit either the contacts or a coating of aluminum and silver. One of the examples which we see is in the optical disc, which is again an electronic device. Optical disc, if you hold in hand and just turn it around, you see a vibrant rainbow color. That is because you have the silver coating. And the silver coating, to achieve the gas delivery technology is used, because you keep what we call as a sputtering target, bombard the target, which is typically a pure silver target with high intensity electrons in an inert atmosphere. If you want to maintain an inert atmosphere, you typically use argon, and this is what is used to maintain the inert atmosphere. Blanketing. Blanketing is something which we see in our day-to-day lives. We go to shops, we buy wafers, we buy snacks. When you press them, you will find that it is fluffy. That means it gives you resistance. There is some packing inside. That is nitrogen which is put inside to preserve the food so that it doesn't get degenerated. So for blanketing, what happens? Imagine you eat one packet, it's fluffy. Another one, it's not good. It is because probably they are not using this technology. But if you use some real branded, reliable products, each of them maintain the same resistance. That is because you are able to precisely control how much of nitrogen are you pumping inside each of the packet. As an extension of the technology, I have shown some photographs here. This is all the candy bars, nut bars, and also we see this cereals, breakfast cereals. You have observed that you take, for instance, brand A. I will not name the brand. Taste it today, taste it 1 month from now, taste it 1 year from now. They all have the same flavor. So this flavor is possible because we have deposited the flavor concentrates using mass flow controller technology. Even the ice cream which we eat. Having said all this, the extensive usage of the mass flow controller technology, which is gas delivery, is used in the semiconductor processes. In semiconductor processes, one of the main applications is creating vacuum. Second one is creating an inert atmosphere. Third one is using high purity, probably toxic gases also to use one of the major operations in semiconductors to produce devices, P-type, N-type. So the same technology is used again in optical fibers. So we always say, eat well, drive well to work in a good atmosphere, take care of your health, make sure that you produce very good electronic products because they influence your life. Electronic products we see today, starting from our laptops to mobiles to various electronic gadgets, including games. So in all this, some of them you find that they are very fast in response. One of the contributors to that speed is this, because the higher speed you get, again a better product which improves. It's like a chain. So I would say gas delivery technology is a critical aspect of semiconductor products which gets used even in our day-to-day lives. So to more about, we will take the next session where we will talk about the construction details. Thank you.